Welcome to lecture on physics 4 to sound waves. Now, already I've written something short on the board. I said, I believe you've come across the word wave before. We've talked about wave in previous lectures in your secondary school. Now, whenever you hear the word wave, we're talking about a disturbance, precisely, just a disturbance that occurs in a particular medium which causes a displacement in the medium, although the particles that remain unchanged. But we have various types of waves, and they vary from based on their medium, both the mechanical waves and the electrical wave, electromagnetic wave. But presently, we are going to be specializing on a type of wave referred to as sound wave. Are you guys with me now? Yes. I'm talking about what? Sound waves. Sound waves. Now, the truth about the matter is that it is not impossible for you to understand sound wave when you don't know the concept of wave. Yes, sound wave, in fact, it stands on its own. You can understand sound waves without knowing even the meaning of waves. That's the truth. You get it? Now, what sound wave? Sound wave is a form of longitudinal wave. Very important key point there. Longitudinal wave that travels in the medium, such as what? Air, solid, and gas. So that the sound can travel in both air, solid, and gas. Of course, you agree with me that if you are just imagine, listen. Imagine if you were to be in a swimming pool, deep down in the swimming pool. You know at the top. Somebody who is 522 foot can hear what you are saying. And the sound can also travel even in water. I get me now. So that's what I mean by that are able to travel in what? Solid, liquid, air, solid, and what? Gas. Now, what I said? Liquid, solid, and gas. Are you together? Liquid, solid, and gas. Now, the speed of sound is dependent on several factors, such as temperature, state of the material medium of what? Propagation. And it's the main factor we talk about this. Now, how the temperature affects sound wave? What you need to put your mind is the higher the temperature, the higher the speed of sound. You agree with me that when everywhere is very cool, do you know that you have observed? If you even used to watch American movies, you see that during their winter fall, I get me now. If they will stop to each other, somebody can be here and try to talk to that person, you have to shout because everywhere is cold. You get it? So that means, but when everywhere is hot, you don't need to talk loud, and they'll be hearing you. You know, so that means speed travels faster in higher temperature. I get what I'm saying now. So the higher temperature, the higher the speed of sound. Very important. The higher the temperature, the higher the speed of sound. The higher the speed of sound. You see that now? The higher temperature, the higher the speed of sound. Now, when it comes to the material medium, state of material medium, it is important for you to know that sound travels faster in solid, then followed by what? Liquid, then followed by what? Gas. So that means it is slow in gas, but faster in liquid than it is in gas, but it's fastest in what? In solids. Do you get the trend now? So we have to also take note of that. Sound wave is faster in solid than liquid and then gas. That is very important for you to know. What's the trend? For temperature, between high temperature and low temperature, which one is speed of sound faster in? Then between solid, liquid, and gas, which one is it faster in? Solid. Are we together? Okay now. Now, there are some terminologies that we must discuss. There are some terminology that we must discuss that we use in sound wave before we move ahead. Let's use the sound wave. I like the matter. This is very important. Let's use the sound wave. There are some terms that we use in sound waves that are very important for us to take with us. Number one, we will use looking at the word subsonic. Whenever you hear the word sonic, it's talking about sounds system. Subsonic. Then number two, we'll be looking at supersonic. Now, when you hear the word subsonic, stop writing. When you hear the word subsonic, something that is subsonic is a subsonic wave or particle is a particle moving with a speed less than the speed of sound. With a speed that is what? Less than the speed of sound. I get what I'm saying now. What I say is subsonic. Good. But supersonic is a speed that is what? Greater than the speed of sound. Write it down. Subsonic, this is particles moving with the speed less than the speed of sound. While the other one is one way with the speed greater than the speed of sound. Questions here? Are you there? Yes. This one moves with the speed less than the speed of sound, have you? For example, now, one thing you must know is that in air, the normal speed of sound in air is 343 meters per second. What is the normal speed of sound in air? 343 Good. 343 meters per second. 343 meters per second. That's the normal speed of sound in air. So anything that is moving greater than that speed, anything moving less than that speed is said to what? Subsonic. So you can say EG. When E is less than what? 343 meters per second in what? Air. Then you see that that is subsonic. But when the speed is greater than what? The speed of sound. That's why it is supersonic. EG, but that is when B greater than what? 343 meters per second in air. That means you are saying that that was supersonic. Is that clear now? Now, having said that now, you can now go to the third term, terminology. You see, these two are talking about speed and this is to confuse people very well. These two was speed. Subsonic, less than speed of sound. Supersonic, greater. But we are not talking about the next one. We are looking at infrasonic, and ultrasonic. Now, infrasonic is infrasonic deals with when the frequency of a wave is less than the normal frequency of sound. You see now we're talking about what? Frequency. When we're talking about sub and super, we're talking about what? Speed. So infrasonic, that's when frequency is what? Less than, when you say something is infra, like inferior, less than the normal sound frequency. So I say that in that case, frequency is less than 20 kilohertz. But the normal frequency of sound is 20 kilohertz. Then for ultrasonic, when what? Frequency is greater than the normal sound frequency. And when we say the normal sound frequency, what are we talking about? That is when N is greater than what? 20 kilo. You know 20 kilo as same thing as 20,000 hertz. Your kilo is 1,000. Same thing as 20,000 hertz. Hope I clear. All right. Now, we've managed to talk about some of these terms. Now, we're now going to look at some of the relationships, between sound waves and temperature in terms of their formula. In ideal gas, the relationship between speed of sound is different from that of the normal system. Ideal gas, a gas that in which the molecules do not interact. I've done that before. Now, the speed of sound in that one is different, which we'll be treating later. Now, in a normal system, is the relationship of speed of sound. You can write NB. The speed of sound varies directly as the square root of temperature. Varies directly as the square root of what? Of temperature. So what are we saying? That B is directly proportional to what? Square root of what? I'll tell you this happens on teaching guys duration. So it means that when B is increasing, what will be happening to T? It will be increasing direct relationship. Okay. Now, how do you remove this thing? This proportionality sign. You bring your equal to K. So that you are saying that B is equal to what? K square root of T. Make K the solid of formula. Divide by what? So we will now say that this square root will cancel this square root here. So automatically you are left with what? K equals to what? B over what? That gives us the relationship for sound waves and temperature. And what's that? You can now say that B1 over square root of T1 is equal to what? B2 over square root. That's the relationship. Very key. Very, very key. This relationship all begins from where? From here. Very important. Very, very important. Write it down. We're using it to solve later on. Let me just put it here. One. Let me see, I think the question is that. That's a question you will check in Japoli. Now, this is the normal system, abi? But in an ideal gas, it is quite different in an ideal gas. Relation speed of sound in an ideal gas. Speed of sound in an ideal gas. Ah,